We're now going to get acceleration from our velocity time graph. Now remember, acceleration is the rate of change of velocity. If we have a velocity that starts out here and is making its way down, our acceleration is going to be negative. The rate of change is simply the slope. I can draw a triangle if I have a straight line anywhere underneath it. Find the rise, in this case -4, the run, in this case a 4, and my rate of change is -4 divided by 4. And that's valid from here all the way to here. As long as I'm along a straight line on my velocity time graph, my rate of change is constant, and in this case it's a constant -4 divided by 4, or a constant -1. So my acceleration right up to this point is a constant -1. For this segment, my velocity is not changing. Acceleration is the rate of change of velocity. If velocity does not change, you have no acceleration. Remember, zero acceleration does not mean you're not moving. It just means that the way you're moving is not changing. Specifically, your velocity is not changing. So with constant negative velocity here, I have zero acceleration. Here, I have a rise of 4 and a run of 4. My rate of change is 4 divided by 4, which is 1. So I have acceleration, or rate of change of velocity, at +1. Here, my velocity is 0, and it stays at 0. So if my velocity is not changing, my acceleration is 0. Here, as I go over 4, I go up 4. So my rate of change is 4 divided by 4, which is 1. And now finally, I have a constant velocity of +4. But because it's constant, my velocity is not changing. My acceleration here is 0. So I have what looks like steps. I have an acceleration of -1, acceleration of 0, acceleration of 1, acceleration of 0, acceleration of 1, and again 0. Everywhere along here, my acceleration matches the slope of this line. My slope is -1, my acceleration is -1. My slope is 0, that's, remember, my velocity time graph. My slope is 0, acceleration 0. Slope is 1, 1, 0, 0, 1, 1, 0, 0. That same relationship actually happens here. My velocity is the slope of my position time graph all along. So in the last video, we drew our position time graph based on finding the area under our velocity time graph. But if we take a second look, see how our rate of change on our position time graph here starts out positive, makes its way to 0. Right? Steepness starts out up, makes its way down to 0. Our velocity starts out high, makes its way to 0. Now our position has a rate of change which becomes increasingly negative. Our velocity becomes increasingly negative. Here it is negative at a constant rate. Here it stays negative. Now here our slope increases from that negative up to 0. Our velocity increases up to 0. See how here it stays flat? It's 0 all the way here. That's 0 all the way here. As our velocity increases, correspondingly, our rate of change of position increases. So by increase, I'm talking about the change in the steepness of my position time graph. So with this constant forward velocity, we have a constantly changing position. But see how the rate of change remains constant? This pen is getting no steeper or more shallow as we go.